We're just going to wait a little while for people to filter in. We started just a bit early. Just a few minutes. Thank you for joining us. Hello, everyone. We're waiting just a little bit for a few more people to filter in before we start. Yeah, so if you're noticing the handout, we won't, and unfortunately, yeah, it's going to be from the last conference. We won't actually be distributing a handout for this one. Okay. So I know how to kill time. I'll just talk about what we're doing today. So welcome to the third session of the Whole Tomato CodeFest C++ Coding Camp. Thank you so much, everyone, for joining. We're going to have several more, and we're excited about every single one of them. I am Christopher Gardner, the lead developer for Whole Tomato, and I'd like to talk a little bit about the webinar series in general. So we're doing a series of videos where a series of webinars that we want to be accessible, want to teach you something about C++, want to improve your skills. They're generally short focused sessions. They're going to be less than an hour. And today we're going to be talking about modern C++ with modern 3D, which is one of the most interesting, which is a very interesting topic. So I'm excited to see this, certainly, as someone who's into game development, who likes that kind of stuff. This is the kind of homework that we need to be doing in order to do a better job at our games. Before introducing our presenter, we have a couple of notes. So we'll have a Q&A at the end of the webinar, so please submit your questions. I can see a couple of people already know how to use that, but there's a question tab that you could use to send us questions, and we'll get to those at the end of the webinar. The webinar will be recorded. We're uploading it to YouTube, so do subscribe to our channel. This webinar is sponsored by Whole Tomato. Whole Tomato is the maker of the Visual Assist plugin for Visual Studio. If you're a C++ or C# developer, certainly give us a try. Download will improve your workflow. There's just so many features in Visual Assist. It's a very popular tool. Okay, so let's get to our presenter. So it's Dr. Yilmaz Yoru. It's in Eskişehir, Turkey. He's got a PhD in engineering with postdoctoral work. He's a CEO of an energy analysis and consulting company, and he's been programming C++ for almost 4 decades. He first moved into programming with his father's computer lab in Amistad Basic. Oh, Basic was one of his first languages, was mine too. On the 1980s Amistad CPC. He moved on to other languages, C, C++, Pascal, Amiga, everything you could imagine. Moved to develop CAD applications for Amiga PCs, and now he develops C++ apps for Windows, iOS, Android, and CPP Builder. Especially enjoys using FireMonkey projects with engineering applications. In his spare time, he enjoys chess and tennis, as well as other sports. So now that we've talked a little bit about our presenter and we've given plenty of time for people to filter in, I'm going to hand the floor over to Dr. Yilmaz.
Hello everyone, welcome to C++ Summer CodeFest today. This is Yilmaz Yoru. Today's topic is modern C++ with modern 3D. This is a journey to modern 3D with modern C++. This is not about only 3D graphics, it is also about 3D analysis and calculations. I'm a mechanical engineer. I'm founder and CEO of Essential Company, and I'm developing since 1988, mostly in C++ programming language and maybe other 30 different programming languages today. I am Embarcador MVP. and C++ Builder developer, author and presenter of C++ posts at learncplus.org and blogs embarcadere.com. I am also developing 3D engineering applications and designs and other gaming tools, and also I am playing games, and I do other activities for kids and education too. Before starting to my presentation, screenshot images are from my applications. I will give you examples mostly in standard C++. Some are specific C++ builder examples. I can say mostly they are compatible with any C compilers today. And I should note that codes are not optimized. Generally, they are for teaching. So there might be better options, better versions. Actually, I tried to add some important parts of C++. How much modern this presents, I don't know, but I am sure there can be part 2, maybe part 3 of this presentation later. And other captures are mostly from the Wikipedia, and code examples are generally from learncplus.org and docwiki.embarcadere.com. Why C++ preferred in 3D? Actually, there are many reasons, but one of the most reasons is it's a compiler language, non-interpreted, and it is very, very close to assembler language. That means it's building very close to the machine language applications, and it is very fast. It has a perfect memory, CPU and GPU management, popular, and supports C language. C language is also very popular. I don't know why they are separate them, C and C++, but they are both together really amazing, and they are both good in math and physics. And thousands of libraries with billions of comments are accessed in the world, so you can find many examples, many libraries. And there are many SDKs that has C++ libraries, examples, and many other things. And also 3D engines and other C++ IDEs with 3D supports C++, and so it is very powerful on designing, calculation, analysis, and graphics. So why other languages are in 3D? Some other languages are compiled languages, non-interpreted again, and they are good, like C language or Delphi language or maybe other languages. And interpreted languages are using C++ modules, like Python, and DLLs, static libraries, and other libraries can be used with other interpreted languages. So there is no problem if you are able to show something 3D with these kind of languages. And there are user requests for 3D games and applications, so game industry forcing them to support these kind of things. And also we have better hardware systems today for very simple graphics, so you don't feel how much this language is slower or how much its performance. So because we have very good graphic cards, very good CPUs and other things. This is why other languages are in 3D. C language is a subset of C++. So before the C++, let's look at the features of C in 3D. C is a very popular language in the world and fast and good in 3D. It's very fast in memory usage, also CPU, and array and struct is very powerful in this language. It is easy to use in 2D and 3D matrix. Now, let's look at the features of C++ in 3D. C++ compiler compatible with C codes. That means all the power of C you have in C++ compiler. C++ is object-oriented programming language. That means you can have many objects and many subsets of the objects, and you can reach each of these objects without losing any speed by using object-oriented programming skills. It is safe in memory usage and CPU usage, and it has many modern computational libraries for analysis and other 3D operations like rotation, using matrices, vectors, etc. For example, boost libraries, eigen libraries are such as examples. And it has many open-lib SD keys and headers, and it has static dynamic libs and modules in C++. There are multi-thread applications and parallel programming in C++, so it is very important to use all the power of your hardware. Classes are one of the most powerful features of C++, and there are many features in classes. You can use private, public, or published features, or you can inherit from other classes, or you can use many other features in classes. And there are constructor, move, copy features, and also destructor feature you can use. You can define your destructor, your constructor in operations of every classes, every objects you create. And there's also a move operator and copy operator that allows you to move and copy with operators. And you can also delete or default these kind of features. If you are using very small amount of data, you can use C-style array or std array. These kind of data structures using stack allocation, where the allocation happens on the contiguous blocks of memory in the function called stack. There is also another allocation, heap allocation, where the memory is allocated during the execution of instructions written by the programmers. So if you want to use heap allocation, there are many other options in C++. One of these is vectors, and vectors are a modern and very flexible forms of arrays in C++. Maybe they are kind of like modern linked lists in vector forms, and you can use them very safely in the memory. And the main difference is they are using heap memory. That means you can use large amount of data in vectors. And another feature is std-map. std-map is a sorted container in the C++ standard template library. It stores key value pairs with unique keys matched to a value. Each member of the container has unique key value and a mapped value. Two mapped values cannot have the same key values in this kind of map application, data structures. When using the std-map, key values are sorted by using the comparison function compare, for example. In C++ Builder, there is another feature, dynamic array. The dynamic array template is a C++ implementation of Delphi dynamic array types. So you can use dynamic array if you want to use resizable arrays in C++. Another two important features of C++ are lambdas and templates. Lambda expressions allow us to write an inline expression that can be used for short snippets of code in our C++ codes. And these are not going to be reused, and they don't require naming, so you can use very, very effectively. Template is a very powerful statement in C++, and they simply defines the operations of a class or a function or an alias or a variable, and lets the user apply the same template on different data types in those template operations. For example, you can create one template and you can use this template on floating operations, on integer operations, on Boolean operations. And there are smart pointers in C++. One of these unique PTR, and unique PTR is a smart pointer that manages and owns another object with a pointer. When the unique PTR goes out of the scope, C++ disposes that object automatically. That means you don't need to delete or free the object from the memory. It's very useful and very powerful in C++, I think. And if you are able to, try to use unique PTR as much as possible. When you are developing a 3D application, one of the most used function is sorting algorithms. So C++ has std sort, and you can use std sort on these kind of operations, and you can use with arrays, vectors, map, or any other features. You can also use lambda and templates when you are using std sort. So it is very powerful and useful and faster on these kind of operations. C++ is very powerful in parallel programming, in multitasking application, multi-threading applications. And when using parallel execution, you need the execution policy, and there's a std execution policy that allows you to avoid data races and deadlocks. In C++ Builder, there is a parallel programming library, PPL, in RTL library. It gives you run tasks in multi-threading processes, and you can use this PPL in a number of features for running tasks, joining tasks, waiting on group of tasks, and other processes. For all this, there is a thread pool that self-tunes itself automatically, so you don't have to care about the creating or managing trees for these purposes. Actually, these are only a few examples of C++ that has many powerful features, of course. And there are more features in C++20 and C++23 coming. And you can use all of them very, very efficiently in memory and CPU management. As I said before, on the CPU side, you can use multi-threading applications with different C++ features like T-parallel for loops or sort algorithms, execution algorithms, or lambda expressions, or in other maybe templates or other concurrency applications like trees, atomic, and mutex. So all these give you to use CPU efficiently and with the maximum power. On the GPU side, there's stdexec in NVIDIA C++. It's an experimental reference implementation of the Sanders model of asynchronous programming. It is an adaptation into the C++ standards, and this is requires C++ C-lang 12 with C++20 and newer CMake and NVIDIA HPC SDK starting with the 22.11. And there's another feature, SDD power option in NVIDIA C++. There's an option for the GPU and option for the multi-core, so that can be used. Actually, as a programmer, I don't want to do more deep in details, but I just want to use CPU or GPU or both of them together. So there should be a standard to use these kind of applications very easily in competition or in 3D applications. So still there's no standard yet, but maybe in C++26 there's a GP support coming, and we will see what will happen. Pixels are the real graphics in programming. If you are playing a game or doing something in 3D, be sure that everything is about the change of the colors of the pixels. So color management and color applications is very important in programming, especially when you are using colors or manipulating colors or doing alpha key management or other things in 3D applications. So a color object is ARGB object, and A is the alpha part of this RGB, and RGB is red, green, and blue. So every pixel has these features, so these parameters. So you can manipulate two-dimensional pixels uh, with a good, very powerful mathematics. So you can rotate any 3D object by changing the color of the pixels. And in C++ Builder, there are shapes for two-dimensional graphics, and there are other layouts, and there are many effects for graphics. So maybe you are developing 3D game or something, but you need some two-dimensional graphics, so you can use it very, very efficiently. Computational and applied mathematics is one of the important part in science, and C++ is very powerful in this field. And when you are doing a 3D animation or 3D analysis something in programming, you need to display this kind of data on screen in two-dimensional vectors or three-dimensional vectors. So you need to use arrow vectors, hedgehogs, and so you can use many different vector types with these kind of analyzers, and it's very powerful to analyze many data on grids. So you can simulate, for example, a supersonic plane by using these kind of computations. When you do programming, sometimes real mathematics is not same in real in programming. For example, there is a tangent to function, this is an example. So if you have 2 points of the vector, you can find the angle of this vector, you know. So, but a tangent function is not working very well in this particular problem, because there's two solutions. It can be on the one side or on the opposite side. So there is another function in programming, a tangent to. So when you do this kind of analysis or applications, you should also know these kind of different functions and applications in programming. Matrix forms are the most used forms in 3D programming. They are easy to use in math and physics, and in linear algebra, a rotation matrix is a transformation matrix that is used to perform a rotation in the space, Euclidean space, and you can define these kind of matrices too. So you can analyze your 3D problem or simulation or anything by using matrices easily in C++. You can use C-type arrays, STD arrays, vectors, or other data structures, maybe structs you will use to apply mathematics and physics. And also you can use implicit and explicit formulas to find maybe millions of data on the grid. For example, you are trying to find the thermal distribution on a surface of the CPU. So you need a 3D dimensional matrix, and you need a 7 diagonal matrix, 2-dimensional matrix to solve this kind of problems. And in 3D, rotation matrix is very useful for rotating vectors, rotation of the objects, and projection, maybe 3D projection, and robotics, physics, and mechanics. Our screens are two-dimensional objects, and we are playing 3D games. How this happens? Because they are using rotation matrix, and this matrix gives us the exact coordinates of the 3D object on our two-dimensional screens. This is a general 3D rotation formula here, and there is a very simple 3D rotational matrix example how you can rotate object. So when you multiply any object with this rotation matrix, you find the exact position of the next level of the vector. In modern 3D, while it is a two-dimensional formula, there is a Euler formula, a single parameter for two dimension, but it can be somehow used in 3D operations as shown here on the 3D visualization of a sphere and the rotation about the Euler axis E by an angle of theta. So this is a kind of solution maybe for another 3D applications and maybe simulation or analyzers. And when we are talking about the 3D, there's another option to use in mathematics, Quaternions, and C++ Builder supports Quaternions partially, I think, but there's a boost library also you can use in C++ Builder and in other C++ compilers. So you can use Quaternions if you are thinking to use Quaternions in 3D applications. And more, maybe octonions or other sextonions, septonions, other parameters maybe you can use in C++ because it's possible to use all of these mathematical formulations and all of the mathematical theories. And there is also rotos in discussion before, and maybe that could be a solution, but these are very futurist solutions for very high level mathematics. C++ programming language is really evolved in many years. I'm a 35 years programming, so I see every levels of the programming language in changes, and there are integrated 3D designers in C++ IDEs. It is very, very important, I think, when you are developing a very useful small application. You don't care about 3D engine, you don't care about anything, and you are just dragging and dropping and connecting 3D objects easily, and you can do animation or movements very easily. In RAD Studio, I try to design this very simple character object as shown here. It took my 30 minutes, maybe less than that, but when I tried to code this alone, creating each object and positioning each of them, connecting each of them, it took my 2 hours. So this shows why 3D designers are important in programming, because we don't need to spend more time on coding. We should use as much as efficient our time in developing applications. So I like the RAD Studio Viewport 3D when we are trying to use this kind of simple applications objects to analyze something or to display something in scientific reports or any other visualizations. So it is very important feature. Another feature is timer component. You can add timer component to any application, so you can check in intervals. For example, every 30 milliseconds you can check every object and then you can move all of them. You can apply physics or other things. So timer components is very useful, I think, in these kind of 3D applications in C++. In this example, I try to run this character object by using mathematics and coding only, without using any motion capture or any emotional data. So I use a sinus function to define a radian value, which is a sinusoidal motion, and I also use other sinus and cosinus parameters with this radian function. So it is not perfect, of course, but very, very smooth and nice when they are moving. In modern C++ IDEs, there are animation features and other 3D options, so you can use them to develop applications. For example, you can use heat detection on 3D objects, or you can use on hit key down, key up events on mouse down, mouse move, or mouse up events. And there are many other 3D options. You can create 3D shapes very easily by you can change their parameters, the size, depth, and length, and or other features. And you can also insert mesh objects, which means you can insert mesh data to this kind of 3D applications easily. And you can add camera, light, and dummy and proxy objects, and you can add animations on these kind of objects. Today, AI is integrated with the graphics, and graphics is integrated with AI. So if you are developing an AI something, you should visualize graphics in 2D or 3D, and maybe you should do some animations to see the behavior of the animation simulation. And if you are developing a graphic, maybe you need AI application to do it better or to run this application better. So 3D games require AI applications, and 3D visuals are good to understand these kind of AI behaviors. And C++ is very good to analyze in 3D in these kind of many different probabilities. And there are three libraries, AI libraries, that you can use in C++ today. And one of these Cafe, another is MLPack, and the Flashlight. In C++ programming world, there are many libraries. Most of them are free or very low-cost libraries that you can use in applications. And some of them are very useful in mathematics. For example, Boost library is very good. Maybe Eigen library. Maybe DevLab Studio libraries you can use it. And OptiVec is another library that you can use. And these kind of libraries can be found in Rust Studio by using the gedit. And you can check these kind of libraries. And there's a comparison table in the Wikipedia. Maybe you can check these libraries, comparisons in Wikipedia. So they are very useful to develop 3D simulations and applications and calculations. If you are developing a very professional game or another very beautiful rendering application, you need 3D engines. OpenGL and DirectX 12 is one of these. Maybe they are library, but I think they are engine too, so I added it here, while they are not considered an engine. And there's Vulkan engine and Unreal Engine, Unity 3D, they are very powerful. And I like O3DE, previously Amazon Lumberyard, and Crytek engine. It's also very powerful. So they are very useful with C++, so they have many examples when you want to develop an application in C++. In 3D graphics, one of the most important parts is rendering pipeline. It's very important to give you most beautiful graphics in 3D. So actually it is very complex, it is very detailed, but there's a brief story. It's called very short pipeline. And in 3D graphics, there are vertices, a point where two or more curves, lines, or edges meet. For example, on the cube, corners of the cube are these kind of vertices here. And shaders are a restricted programming model that is designed for the parallelism of GPUs and to mesh with the graphics pipeline. And by using these, you are rendering 3D object with the beautiful colors and lighting and other features of texturing and rastering, etc. To do this, simply, according to Vulkan, you have data, you do rasterization, and you give the rendering output. And optional, there's a vertex shader and fragment shader. And in Kronos group, there's vertex specification, vertex shader, tessellation, geometry shader, vertex post-processing, primitive assembly, rasterization, fragment shader, and per sample operations is these kind of steps. And in rendering pipeline, there's also another steps in graphic cards or in graphical applications on our GPUs. And NVIDIA is showing this as shown here. And you can use CUDA, physics, RTX, DLSS, or other applications with NVIDIA C++. I hope all this brief information give you some benefits of the C++, why we are using C++ in 3D and why it is important in 3D applications. And it is also very good to summarize the power of the modern C++ in today's modern graphics. So yeah, it is not enough. Maybe there are many features to talk here, but it will take a lot of time. Maybe in another presentation we can discuss other features of the C++ and more other new modern techniques and methods that we can use in 3D applications. Thank you. And if you want more C++ examples, you can visit learnc++.org. And if you have any questions, you can directly email me about these kind of problems or other situations. Thank you very much.
Right, thank you, Dr. Yilmaz. If you could pause it there, so we could have a screen to show. So now we've reached the end of the webinar. We've got some Q&A. So if you've got questions, please just type them into the little questions tab. And we've got Dr. Yilmaz available to answer them. So we've got a few questions in already. So Yilmaz, what are SDKs? That's an early question we had.
SDK, hello everyone. Hello Chris also. SDK is a software development kits. They are a very big amount of source code and that some companies giving this to you so you can develop application with their rules or with their libraries. For example, Steam has Steam SDK. So you can, if you are developing application on Steam, you can use Steam features like Friends or other things. So you have to use their SDK. So they are giving it free. Generally, mostly all SDKs are free, but some SDKs are may require payment also. That's it.
All right. Thank you very much for that. We have another question. Could you give an example of when someone would use STD map?
There was an example, very short example. In 3D, we have many objects. As you can use STD map when you are using objects. For example, you have many different bots or types, and they have names, maybe heights or other parameters, floating, integer, string parameters. So you can use STD map with this kind of different parameters. No, I don't know, but I remember the STD map, and I found it's useful in this kind of some applications. Maybe you want to sort them by their name, you want to sort them by their height or by their weight or size, something. So in 3D operation, it's very important to have different kind of variables in one stack, in one structure.
All
I
right.
hope
Thank you,
that
Doctor.
helps. Yeah.
No, I think that nailed it. All right. So about quaternions, could you explain a little bit more about quaternions and maybe what the difference is over regular angles, or would someone use quaternions over Euler angles?
Quaternions are about rotation, and there are some mathematical benefits when using quaternions. Actually, I was also doing some tests in the last few months about. I have some theories, so I am also doing some search. So I was trying to use quaternions in 3D in different operations. So they have some benefits when you are using 3D rotation or other applications. So while there are four parameters, the first parameter is real number, other are complex numbers, E, J, and K. And it is benefit to have four parameters. The real number can be rotation angle, or real number can be maybe vector size. I was searching for it. Maybe you can use quaternions wisely in other operations. It is very popular in graphics since the last 10 years, I think. They are using mostly, but I am not very detailed about how they use, how they do it. But it's another option. I just put these kind of options. If you are developing 3D applications, maybe you can speed up your code or your visualization faster by using these kind of mathematical other solutions.
All right. Thank you. So we have a couple of people asking if they could get slides for this presentation. So there's not going to be slides for this presentation, but a recording will be available on the Whole Tomato YouTube channel. So go ahead and check there. Just as a personal note, I recognize Eigen when you're going through the math libraries. TensorFlow uses Eigen. It's definitely a good math library. And we've got someone who said they're looking forward to GPU support in C++26, and I certainly am myself. So let's cross our fingers there.
Yes.
If we've got any other questions, if anyone wants to shoot them in before we okay. Oh, so how would someone who's interested in AI in C++, do you have any advice to get someone like that started?
What you mean? Of course, I advise C++ and AI together is very well. What you want me?
So they were just wondering how to get started. Like, where should they start? Where can they maybe like learn, or what library they should use?
Coffee library is very good in C++. It is also used in Python, and you can also use Python in C++, or you can use C++ in Python too. I think I prefer C++ alone without Python. If you are very good in math or other things, you can do all alone. But if you don't want to spend more time on AI things, doing filtration, transportation, or transfer of the matrix or softmax, etc., then you can use TensorFlow easily. But in specific problems, you always need a specific feature for your application to do faster and better. So C++ is the best, I think, for those kind of problems. Maybe a little hard, maybe a little longer, takes time, but much more useful, I think. I thought this.
All
I
right,
hope
thank you,
some,
Dr.
yeah.
Yilmaz. Yeah, no, I think that was a perfect answer.
Mhm.
All right, so that's our questions for now. So we will wrap up. That's been Dr. Yilmaz with Modern C++ in 3D. That was an excellent webinar, so thank you so much for joining us.
Thank you.
And we will see you at the next webinar, everyone. Thank you very much.
Thank you. Have a nice day, everyone. Bye-bye.
Bye-bye.